Okay, so I think that is a good time to get our class started. Good afternoon, everybody. So we need to wrap up the materials today, and then at the end of today's class, we're gonna discuss briefly about the preparation for the final exam. Right. All right. So let me go back to the subject matters that we have. Last time we did the module 11. So let me share with you the class notes for module 11. All right, there are a lot of things here. Okay, this one right here. Okay, so module 11 is a fixed period system, right? That is the opposite of module 10. In module 10, we fix the quantity that we order every time, and we let the time between the orders to vary so that we can catch up with the changes in the demand, right? In module 11, we do the opposite. So we, instead of fixing the quantity, now we fix the time. We fix the time between the orders. And then we let the quantity to vary depending on the demand. So if demand is high, then we need to buy more to catch up, to make up for the difference, right? And if demand is low, then we will not order much. We will order less because the demand is low. All right, so that's the essential feature of this module 11, or the fixed period system model, right? So let me review the main points of this example, and we would move on to module 12. So in this example, or homework 4, question 25, first of all, we would calculate the EOQ. Well, we will not order the same amount every time. We just take this Q star as a step so that we can calculate the time between the orders that we need to fix, right? All right, so that part A, we calculate the EOQ like in the module 10. And then in part B, we calculate the average number of orders that we might make in the year. So after we calculate the average number of orders, now we can calculate the time between the orders, right? So so now we have a hint or a clue of how many days we wait before we make the next order. And in this case, the TBO is 13 days, right? So we make an order today, then we wait for 13 more days before we make the next review and the order. Right? So that's the main idea of this system. In part C, is short and easy, right? Where the current inventory or the current stock equals how many on hand, how many that are delivered today, and then minus the back orders, right? So in this case, we talk about the current stock of 25 mil jugs. All right, in part D, now we talk about the MAD. So MAD, the word M, the letter M stands for the maximum, right? So that's a maximum level, the ceiling, right? The maximum of the ceiling. So we either call that as a maximum inventory level or the replenishment inventory level, right? So in this MAD part, we only commit ourselves to solve to the average demand. So demand is depicted by this distribution, right? Demand is fluctuating, but we only carry enough to solve to the average demand during the T plus L. By the way, we have the T plus L because we have to wait for 13 days before we make the next order. But then we do not receive the order right away, right? We have to wait for 3 more days to receive the actual merchandise. So that's why the time window that we are interested in is 13 plus 3 or 16 days ahead of us. So we try to retain enough inventory to sell to the average demand during the next 16 days, right? So that's the idea. So that's why the service level is only 50% because we only try to solve the average demand. The calculation itself is not difficult. You calculate it per day and then you scale it up to the 16 days and you have the maximum level, right? So the ordering rule goes as we need to review our inventory every 13 days. And then on the review day, we try to make up for the difference between the maximum level and what we have right now or on that day, right? So we take the maximum, subtract the inventory position on that day so that we know, oh, that's a deficiency. We want to go back to the maximum level and that's a deficiency. So we order that amount, right? Okay, so if, and in that case, we take the maximum level, subtract the IP, and then we know how many meal jacks that we need to order on that day, right? As an illustration, then we drew this diagram, right? It is we track the inventory over time. So we know that we're gonna wait for T days, but this is a interval that is before we make the next review and order, right? All of this happens at the average. So we plan as the original plan, we're gonna review it every 13 days, right? And then we have to make the order, and then we have to wait for 3 days for the merchandise to come, right? We can specify the lead time right here. The maximum level is at the top right here, right? So assume that on day one, we start with the maximum level. Then over time, the customer will come and buy, so our stock will go down at this day by day. The steps that you see here should not be even, because some days the customer buy a lot, and another day the customer buy little, right? So the step going down here are not even. So on the review day, we see that, oh, that's a deficiency amount, right? Then we order that Q1 as the maximum minus the IP on that day. And then at the end of the lead time, we would receive that amount. So the inventory jumps up like this, right? And then it continues to go down. So that's the end of the first cycle. And then we start with the second cycle. On the review day, we try to make up for the difference by ordering Q2. And then at the end of the lead time, we receive Q2, right? So here's the thing, if we do not sell anything during the lead time, then imagine that the pot right here will be totally flat, right? If it is flat, then at the end of the lead time, when we receive the Q2, then we will jump up exactly to the maximum level, right? And that's why we call it as a maximum level. We will never go beyond it, only either at that level or below that level, right? Okay, so the cycles will happen multiple times in the year. All right, so in this model, obviously we fix the time and we allow the quantity that we order to vary, right? So if demand is high, then the point out here will be lower. Then we will need to make a bigger order, right? So that we can make up for the bigger difference between the maximum level and what we have in stock, right? So I hope you already have the intuition on how the system works, right? And then in part E, the final part of question, the example, of the question 25, we try to do more than before. Earlier, we only carry to solve to the average demand, right? But this time around, we carry some extra stock. We call that as a safety stock, so that we can reach a higher inventory level so that we can sell more, we can serve more, right? So if we can climb up to that higher maximum level, then we're gonna have a higher service level, right? So we call this as a maximum level with the safety stock, or MSD. So MSD in this picture just equals the average demand plus with the safety stock. To find the safety stock, you would multiply the Z value with the standard deviation, right? So the Z value here just tells us from the mean how many steps we need to walk up before we reach the maximum level, the the maximum level with the safety stock, right? So that's the meaning of the Z. How many steps we need to walk up? And each step is one standard deviation, right? So as a calculation, like before for the average, we just calculate that per day, and then we multiply with the days in the 16 days ahead of us, right? And for the Z value, you would type in Excel equals norm dot s dot inverse, and then the service level, which is 85%. Then you would have that 1.03643, right? The value of the Z value right here. And then we will need to find the standard deviation per day, and then multiply with or scale it up to the 16 days ahead of it, right? The sigma D here is only for 1 day. So we need to scale up for 16 days. If it is a variant, you would multiply directly with 16. But here we talk about the standard deviation. That's why you wouldn't need, the standard deviation is a square root of the variance, right? So that's why you see that square root here, because we talk about the standard deviation rather than the variance. If it is the variance, then you just multiply with t plus L. But because we talk about the standard deviation of the standard deviation, which is a square root of the variance, right? That's why we have that square root symbol that shows up. It looks like from nowhere, right? But actually, that's a mathematical property of the variance and the standard deviation. All right, so now to be more specific, we will put the numbers in this equation, right? So 32 per week divided by 7 per day. And then ahead of us, we have 16 days, right? So we multiply per day with 16 days. That's an average demand. In the second part, we take that. So Z now is 1.03, which means that we need to walk up by 1.03 step, right, to reach the maximum level. And the maximum level is calculated by the last two terms here. So per day, we have this, because the question gives us 7 meal jugs per week. So the 7 on the top here is for 1 week. To convert that to 1 day, you need to divide that by the square root of 7, right? For the same reasons as before on why we have the square root. So we have the standard deviation per day, and then you multiply with, you scale it up to the full 16 days, right? So at the end, we have the maximum level to be 84.11, but because we talk about the meal jugs, we will need to route up to be 85, right? So 85 meal jugs as a maximum level. So we follow the similar ordering rule like before. We need to review our inventory every 13 days. And on that review day, we would need to make for the difference, right? We try to make up for the difference. So you take the maximum level minus the remaining stock to see how much we need to order. All right, so yeah, I let you to try this by yourself. It should be easy, right? 85 minus 25. You already know the answer already. Okay, and finally, we need to do the illustration on how the system works. So to help you, I drew the illustration right here. So earlier we talked about the MAD, which is 74. But this time around, we try to have a higher service level. So we raise the maximum level to be higher than before, right? So it means that if we are at this point right here, then we have 85 units rather than 74 units, right? So those 85 units will be used to cover for the next 16 days, from here to here, 16 days, right? Then definitely this time around, we have a higher service level than before, because we start with a higher inventory level, right? Then we have more chance to sell to the customers, so we serve more, or in other words, we have a higher service level. And in this case, it is 85%. But of course, because we route things up a little bit, right? Then our service level will be a little bit more than 85%. So other than that, the picture looks very similar to what we saw earlier. We have the intervals of time where we do the review and order. We have to wait for some time to actually receive the merchandise, right? So on the review day, we try to order the difference between the maximum and the remaining stock. And then at the end of the lead time, we receive the truck or the shipment. Then the quantity jumps up by how much we order, right? And then that's the end of one cycle. And the next cycle continues, then continues, right? So if you are the manager of a store, if you use the FBS model to manage your some merchandise item, okay? If you have the data about the about your items like this, and you draw it like this day by day like this, right? Then it looks similar to what we see here, right? So so I hope now everybody see the intuition or the concepts or the rules, the decisions that managers will make will need to make if he or she follows the FBS system, right? So it's a little bit similar to the FQS model, but the decision is totally gonna flip, right? Okay, so by now I hope we are done with module 11. Does anybody have a question for me regarding this homework question? This one. Are you good so far with the discussion? All right, so I hope you are good. In case, thank you, Jelly, and thank you, Paula, for the feedback. In case if you have anything to ask me, then we still have. Oh, you know what? Our exam. All right, thank you, Marco. We have the exam next Monday, right? In the morning, I have my office hours. So actually, my office hours next week. Let me make it a complete statement, okay? So today is the last lecture day. We will not have any lectures next week, right? Next week we have the final exam on Monday, and then and that's it. And then besides that, I have my office hours from Monday through Friday is that 9 to 10 a.m. Okay, so in the morning next Monday, I have my office hours. If you are not clear about anything, please feel free to get on Zoom. I hope I can clear it up for you in preparation for the final exam. Okay, so other than that, I would like to move on to module 12 right away. That's the last module of our class. So let me quickly discuss what we have to deal with, and then I will show you the question that we will go through. All right, so we are moving to the last module of our class, module 12, about a single period inventories, or SBI. So why do we have to talk about this? Because in the past, we have to deal with the so-called the news vendor problem. In the past, that's an old technology. People write newspapers, the actual newspapers, right? Then every morning they will buy it from the vendors, or during the day they will buy it from the vendors, right? Then for the vendors, they will have to go to very early in the morning. They will have to go to a publishing house and buy a bunch of newspapers, and they try to sell it off during the day, right? The problem is the following: if they carry too much, okay, if they have too many newspapers, the physical newspapers, then at the end they might have the leftover, and the next day those leftover are worthless, right? Because news are day by day. So next day people will buy the next day's newspaper, not the today's newspaper. So that's why if they carry too much, they will lose money, right? And the thing is, if they carry too little, that is also bad too, because if, for example, if they sell off all the newspaper by 1 p.m. or something, then after 1 p.m. when people come and buy, they did not have the newspaper to sell anymore, right? Then they lose the potential profit, revenue and profit because they carry too little. So the news vendor problem is the dilemma between carrying too much and carrying too little, right? And we call it as a single period inventories because they only have 1 day to sell those newspapers. The next day is nearly impossible to sell. Okay, so that's a dilemma. And of course, nowadays we do not buy the newspaper to read the news anymore, right? We go online, we use social networks, things like that, to learn about what is going on around us. So actually, technology changed the way that we live, right? Okay, so um, but then you know what? The news vendor problem still exists, right? Of course, we still have some news vendor. They sell the newspaper at the corners, right? But the things that is more prevalent that we have to deal with nowadays is called a seasonal goods problem. We have many seasons in the year. For example, upcoming here we have the Christmas or other religious holidays, the New Year holidays, and then after the New Year holiday we have the Valentine next year. After Valentine we have the graduation season. Right, some of you might graduate actually, and then after the summer we have the Halloween season, on and on, right? So we have multiple seasons during the year, and the retailers they have to carry the seasons, I mean the merchandise specific to the seasons that are upcoming, right? And they try to sell as much as they can during the season, and at the end, if they cannot sell it, then it's really hard to sell. They will have some leftover, and it's really hard to sell those. So it is the same dilemma that the news vendors will have to faced in the past, right? If we carry too much, we will have a lot of leftover. That costs money. And if we carry too little, we're gonna forego the potential revenue and profit. That's not good either, right? So in this module 12, we will learn on how to strike the balance between carrying too much and carrying too little. When I say strike the balance, it doesn't mean it is a perfect quantity that at the end we just sell exactly what the demand is, right? And not that, because you make the decision. We have to make all the decisions even before the season starts. And what happens during the season is in the future. We cannot know the future for sure, right? We only try our best to make the best decision before the season starts. So we call it as a SBI model, right? So the best thing that we can do here is to try to maximize our expected profits for the upcoming season. Okay, so for example, if we draw the timeline like this, the Christmas season will start at some point and end at some point, right? So that's our seasons right here. Then we need to make the decision on how much we carry before the season starts, right? So we are here. I draw an eye to say that we are here. Right? We look forward. We make the decision even all before the season starts. So the Q decision is made here even before the season starts. So we need to try that. We need to find the optimal quantity so that we can maximize the expected profit. Expected means that so if we repeat this many times, then on average, that will be the expected profit, right? So that's what we deal with here. We are not living in the future. We are living now, right? And then we have to make the decisions for the future. So the best bet that we can do is to maximize our expected profit. Okay, so probably you already read a lot about this on Connect, right? So let me show you the homework question that we would work on right now to see how we do this. So let me show you the question. Okay, so a national pharmacy chain considers selling graduation cards this year, right? So assume that we are in the graduation season. These cards are typically released in February and need to be sold before the end of May, right? After May is hard to sell. So after May, the remaining stock will be marked out to get sold. For each card, the item cost is 0.91, right? We know it is 91 cents, but we need to convert everything to the dollars, okay? So $0.91, the regular selling price is $4.99. The marked down price after May is $0.48, right? So those are the three important dollar values that we want to know. We need to know. All right, the pharmacy historical demand is normally distributed with a mean of 1.82 million cards and the standard deviation of 0.16 million cards, right? So we talk about a national pharmacy chain like the CVS, like Walgreens, right? They sell many cards in the year. So I make up the numbers to see that, okay, it is a national chain, so they sell a lot, right? So the mean is 1.82 million cards, and the standard deviation is 0.16 million cards. So it means that we have to deal with the uncertain demand in this case, right? The demand is not constant, it's not perfectly predictable. So we have to look at the past data to know the average, to know the standard deviation, to kind of make the predictions about the future, about the upcoming season. So in part A, we need to find the optimal quantity that we should carry. In part B, we need to illustrate it by a sketch. In part C, what is the expected inventory or the leftover at the end of the season? Part D, expected sales during the season. Part E, what is the expected profit, right? We try to maximize the expected profit. So what is that expected profit? In part F and part G, we need to find the in-stock and the stock out probabilities, right? Okay, so let me go back to the whiteboard and work on this with you. Okay, so let me summarize the question a little bit. We talk about we are still in module 12, and we talk about the example here. And the example happens to be our homework 4, question 24, about the graduation cards. Homework 4 and question 24. All right, so the question gives us that the cost per card is 91 cents, but of course we need to convert it to the dollars, so $0.91 per card. The regular selling price is going to be $4.99 per card. The salvage value, right? Sometimes you see the clearance price. The clearance price is way lower than the regular price, right? So we call it as a salvage value. It's hard to sell, so they try to salvage as much as they can, um, and then have some more revenue to make up for the cost of the unit. So the salvage value is assumed to be $0.48, right? So the salvage value is even below the cost of the item. Beside that, we have to know the demand, right? So we assume that we have the normally distributed demand. Why do we know about the demand in the upcoming season? We look at the past, right? Then we have a better idea of what comes next. So based on the past operation over many years, so we look at the demand over many years in the past, then at least we have some ideas of what might come next, right? It's like the forecasting exercise that we did in module 2. All right, so there are two important numbers that we need to know here. Number one is the average demand, which is mu 1.82 million cards. And the second that we need to know is a standard deviation, right? 0.16 million cards. So if it is a normal distribution, we need to know these two parameters to characterize the distribution. All right, so here's part A. In part A, we need to find the optimal quantity that we should carry for this graduation season. Q star. To do that, then first of all, we need to find the underage cost. It means that if we carry too little, we lose a potential profit, right? So how much is that? So CU equals the price that we would get if we can sell the items, and then minus the cost if we have the item, right? So you would take the price of 4.99 minus the cost of 0.91, then we have 4.08 dollars per card. So if we carry one card fewer than the demand, then we lose this much of our potential profit, right? The other way is overage cost. So CO equals C minus the salvage value. Then you would take 0.91 minus the $0.48. Then the salvage value is 43 cents per card. So if we carry too much or one card more than the demand, then we cannot sell that card at the regular price. We even have to mark it out very cheap, and we lose 43 cents per card, right? Okay, so now we are ready to find the so-called critical ratio. So the critical ratio is calculated as CU divided by CU plus CO. If you write this way, then you will get it correct. All right, so CU divided by CU plus CO. Then we just plug the numbers in, 4.08 dollars per card divided by $4.08 per card plus the 0.43, all the dollars per card to be canceled out, right? So we only have the numbers left. And at the end, our P star would be 0.90466. So it is called the critical ratio, right? To make more sense of it, let me give you the interpretation of it. The critical ratio is actually the optimal service level that we should aim to show in the upcoming season. Okay, so in this case, we should carry enough to have a service level of 90.4% or 90.5%, right? So that's the critical ratio. That's the meaning of the critical ratio. If we carry too little, we will not have that 90.5% service level. If we carry too much, we're going to have 95% service level, right? Then if we operate at 95% service level, maybe we carry too much, right? So the 90.4 or 90.5 service level is the point where we strike the balance between too much and too little. Okay, so that's the critical ratio. With that, now we are ready to calculate the optimal quantity that we need to find. All right, so next we need to find the optimal quantity. Or Q star. It is equal. This is a property of the normal distribution. You will take the average of the distribution and then calculate how many steps we need to walk up, right? So that we can achieve that service level. So the equation says that we take the average plus how many steps multiply with the sigma, which is a one step, right? All right, so to be a little bit more specific, the equation goes as you would take the mean given by the question. The z here is calculated as norm dot s dot inverse of the p star, and then we might multiply with the sigma given also by the question, right? So let's put some numbers in the equation. So q star in this case is going to be the 1.82 given by the question plus norm dot s dot inverse 0.90466, the optimal service level that we try to achieve, right? And multiply with the 0.16. So this is even though it looks long, but it's just a number, right? If you punch equal and then norm dot s dot inverse of 0.90466, then you're gonna have 1.30855. Okay, and then let's go back to the equation. So Q star is going to be 1.82 plus that times with 0.16. So please make sure that you do the multiplication first before you do the addition. Right? That's the rules of operation or the order of operations for that. So at the end, the Q star that we find in this case is going to be 2.02937 millions cards, right? Because from the beginning, all the the standard deviation are in terms of millions of cards. So the quantity at the end that we have here is also in millions of cards. So what does that mean? It means that the pharmacy chain should carry this Q star of 2.02937 937 million cards so that they can maximize the expected profit this graduation season. To be more precise, the upcoming graduation season, because we are not there yet, right? Okay, so that's part A. Let me recap. We calculate the critical ratio first. That's the optimal service level, and then based on that, we can find the optimal quantity itself, right? Now let's move on to part B. In part B, we need to make a sketch to illustrate what we did in part A, right? So that we have more intuition of what we do. So the sketch of the decision in part A, or the sketch of the demand distribution. You want the sketch of the business situation. And in that sketch, we will need to draw the normal distribution. Okay, so we assume that demand varies according to the normal distribution, right? So it will look like the following. I try to draw it bigger. All right, so this is a demand during the upcoming season. Right, we talk about millions of cards. Sometimes the customer buy more, sometimes the customer buy less. Right. So it follows the normal distribution. So the shape up here looks like a symmetric bell-shaped curve like that. Right. At the heart of it, we have the average, the mean, which is 1.82 million. Right. Okay. So we are not solving the customer the average, right? We try to do more. So we need to pin down that quantity, right? Q star, so that on the left hand side, we have the service level of 0.90466, or about 90.5% service level, right? So from the mean, we move it up. We move up to that point so that we have 90.466% on the left-hand side to find the optimal quantity, right? So this one right here is called the service level, because if demand falls here below the Q star, then we will have enough stock to sell, right? We solve the demand. So we call it as a service level on the left-hand side. Or in other words, we also can call that as or we can call that as an in-stock probability. Either way, service level or in-stock probability. And then in opposite, on the other side, we're going to have the stock out probability. Right. So that's the sketch of the decision that we made earlier. Right. We try to carry the Q star so that we will have that optimal service level, and with that, we expect to maximize our profit for the upcoming season. By the way, the Q star, you can label that as a number like this, right? Because we already calculated it earlier. Okay, so that's part B. Part B is just an illustration of what is going on in part A. In part C, we have the following. The part C is a little bit cumbersome. In part C, we need to calculate the expected inventory, or EI. What is the expected inventory? It is a fancy way to say that is the expected leftover at the end of the season. Right. So at the end of the season, we expect that we're going to have this much of inventory. We say expect because we never know the actual demand in the upcoming season yet, right? So on average, this would be how much we might have as a leftover at the end of the season. So the equation goes as the following. The expected leftover equals the standard deviation times with a function called the IZ function, where the Z is calculated as the Z inside the parentheses is calculated as how much we carry minus the mean of the distribution divided by the standard deviation. But of course, in this case, we carry the optimal quantity, Q star. So we take that Q star minus the average divided by the sigma, right? So if you calculate it, then you're gonna see that we are going back to the Z value that we got earlier in the Q star calculation, right? Please feel free to try the actual calculation and see that we're gonna go back to the same Z that we had earlier. Okay, so remember earlier what we did is Q star equals mu plus Z times sigma. So that's why this time if we flip the equation, then we have the same Z like before. All right, so next we're gonna find the IZ function. Now we have the Z, now we put the Z inside the parentheses to find the IZ, right? The IZ looks a little bit cumbersome. It is a result of some integrals, right? So numerical integral, so or integral. So it goes as the following: we have norm dot as dot dist of the Z value comma 0, right? This is an Excel equation, so you punch exactly like this onto Excel, right? And then plus the Z value times the norm dot as dot this one more time, and the Z value comma 1, right? Comma 0 and then comma 1. So now let's put the exact numbers in. The IZ in this case is going to be norm dot as dot dist. The Z is 1.30855 comma 0, right? That's the first part of the equation. The second part is we take Z times norm dot, oh, I'm sorry, Z is a number now. We take 1.30855 as a number, multiply with norm dot as dot dist, not the inverse function. This is a dist function, a distribution function. And then we put in 1.30855 comma 1, right? So either you punch this in Excel or in the homework question, I have the table at the end where you can look up for the IZ, okay? So either way, it should work. So the IZ in this case, if you calculate this, then it's gonna be 1.35326, right? If you're not clear, just punch all of these bulky expression into Excel, and it should come out as 1.35326. Okay, so now don't worry too much about the math. right? Either you punch it in Excel or you use a lookup table that I put at the end of the question. You're gonna have the same thing. In the exam, right? Please feel free to use an Excel equation to do it. All right, so next now we have the EI as a following. The expected leftover is 0.16. Remember, it is 6 times IZ, right? So you take 0.16 given by the question. That's the standard deviation of the demand given by the question. And then you multiply with that 1.35326, right? The IZ value that we just got earlier. Then the answer will be 0.21652. Again, we talk about the cards. So here we talk about the millions of cards. Right, 0.2 million cards as expected leftovers, right? So we can interpret this result as the following. If we carry Q star of we carry the Q star of, let me go back to the Q star that we got earlier, 2.02 937, right? Million cards. Then we expect to have EI equals 0.21652 million cards left at the end of the season. Right. So this policy is I would say the most bulky among all of the parts of this question. But other than that, things are shorter and easier. Okay, so that's the expected inventory. How much we expect to have left at the end of the season. Now, with that, we can calculate the next one. In part D, we need to calculate the expected sales. Or ES, okay? So the idea is very simple, right? So if we carry Q at the beginning of the season, and we know the expected leftover of the season, then we just subtract these two numbers. Then we have the expected sale. Right? During the season, we expect to sell these many units. But of course, in this case, we try to maximize our profit. So we carry Q star, and then with that, we have the expected leftover that corresponds with that Q star. And we already calculated all these two, both of these values earlier, right? So we just plug the numbers in. The optimal quantity that we try to carry is 2.02937 million cards. We subtract the expected inventory of 0.21652, right? Then our expected leftover, the expected sales is going to be 1.81285, right? This is million cards that we expect to sell during the upcoming season. Right, at the beginning, we have 2.02 million cards. We expect to sell 1.81 million cards. Then at the end, we have the leftover of 0.21 million cards. Right, so that's the simple subtraction. So it means that if we carry Q star of 2.02937. Then we expect to sell the ES of 1.81285 million cards. I'm sorry, in your notes, please add the units here, right? So if we carry Q star 2.02 million cards, then we expect to sell these many cards, right? Okay, so that's part D. Is a short part. Part E is the following. We need to calculate the expected profit, right? We make the prediction about how much profit we would make in the upcoming season. So as a manager, we always have to do the pre-calculation like that, right? So that you will know what is the best option to do. All right, so the equation goes as EP, or expected profit, equals, the first term is expected sale multiplied with the regular selling price plus the expected leftover, EI, times the salvage value, right? And then minus the quantity that we carry times the cost per unit. Of course, here we carry a Q star, so we change the Q, the generic Q to the Q star, right? I hope you see the intuition of this equation. This is a regular revenue. That's a salvage revenue. We try to salvage as much as we can by selling off the remaining items at a very low price. And then finally, this part right here is a purchase cost. Right. So we add the revenues together to have the total revenues and subtract the cost. And that's why we call it as a profit, the difference between revenue and cost, right? So let's put the numbers in and see what we got. The first term is 1.81285 sales revenue, sales, the number of cards that we sell, millions of cards, and then multiply with the 4.99 is a regular selling price. The EI is expected leftover, so it is 0.21652 times with that clearance price, 0.48, right? And then minus the 2.02937. That's how many units that we try to carry. Multiply the cost per unit. So at the end, our expected profit is $7.30331, right, million dollars. Everything here is in terms of millions. You should not convert the numbers to the million, right? We just use numbers, and then we say that it is a million of dollars, million of cards, things like that. Okay, so we are done with that part E, right? So from the beginning, we find the critical ratio and then the optimal quantity. And then if we carry the optimal quantity at the beginning of the season, we have the expected leftover or the EI. And then based on that, we can calculate the expected sales or ES. And then we put everything together to calculate the expected profit, right, or EP. Okay, so as a manager, we are interested in all this, right, before we make any decision. If another merchandise items will generate more profit, maybe you choose another merchandise items rather than this item, right? So that's the consideration that I'm talking about. You pre-calculate things and make the best decision for you, for your company. All right, so that's the A, B, C, D, E, and now there are two smaller parts at the end. In part F, we need to find the in-stock probability. Okay, so the in-stock probability conceptually equals the probability that demand falls below the quantity that we carry, right? Of course, in this case, we carry Q star. So instead of generic Q, we can say that as Q star. To be general, okay, let me give you the equation, generic equation to calculate this. So you would do norm dot S dot dist. By the way, we assume that the demand follows a normal distribution. That's why we have this equation. So we take Q minus mu. In this case, you're gonna plug in Q star minus mu divided by sigma, right? So this is called the Z ratio or the Z value, right? And then comma 1. So that's the generic equation. You put in the Q star, put in the mu, put in the sigma, right? And then comma 1, and then you should have the following. But you know what? This one should be equals the P star that we calculated earlier, right? If we use Q star here. Then it's going to be the P star that we got earlier. So you don't even have to calculate, okay? In the homework, you just say that it equals to the critical ratio. So 0.90466, or if you want to try the equation, then you're going to have the same thing, right? So that's part F. In part G, we would have the stock out probability. So conceptually, it's very simple. It is just 1 minus the in-stock probability, right? So it means that you would take 1 minus the 0.90466, then you would have 0.09534. Or roughly speaking, 9.5% stock out probability, right? So at the end, we just put the two numbers into the diagram. Actually, you already have it earlier. We just do it one more time. So this is a demand during the season. So if we carry at Q star, right, then the service level or the in-stock probability will be 0.90466. That's the in-stock probability. And on the other side, we have the stock out. Probability equals 0.09534, right? The two adds up to 100%. So it's easy to draw them in the demand distribution. And then that's it. That's the end of the homework question. So any quick question for me about this thing? All right, so Fallon, in Excel, if you put in 0, then it will not accumulate. But if you so for example, if you put the Q here and then Q star in and then you do the comma 0, then the comma 0 only tells you the height of the distribution right here. But if you do the comma 1, then they will do the cumulative. So they will go from the left-hand side, add all the areas here all the way up to that point, right? So comma 0 means Excel only gives you this much, the height. But comma 1 means that they will give you all the areas under the curve all the way to the up to that point. So that's the difference between the two. Of course, we are not interested in that in our class, right? That's for the statistic class. If I teach statistic class, then that's what I emphasize. That's how I how I explain the difference between the comma 0 and the comma 1. But this semester, I do not teach any statistics class. All right, so that's the end of the homework questions. So I hope that you are ready with question 24 and 25. Please rewrite everything as your own work, right? Of course, you can please feel free to go back to the class note as your reference, right? And please upload that by Sunday's night, because I would like you to be prepared, to be ready, right, before the exam. So that's why I make the due date as a Sunday's night. I hope you understand my intention, right? We should not review the questions after the exam. We have to review it before the exam. Okay, so with that, I would like to move up to the preparation for the exam right away. Let me share that with you. We have a very short time left. Okay, so our final exam is next Monday, December the 6th, from 1 p.m. to 2:50 p.m., right? But actually, you can start the exam at 12:55 or 5 minutes earlier than 1 p.m., right? Please keep that in mind. So you have five more minutes earlier. And after 2:50 p.m., you would have 15 more minutes to wrap up your written work and submit your PDF file. Okay, so please observe the timeline. So 5 minutes earlier, and then submit all the other things at 2:50. And for the written work, you would submit that around 3:05. Right. So everything here is on Canvas. I would give you 15 questions in total. The first 10 questions are multiple choice and only for 20 points. So you should not spend too much time on the 10 multiple choice questions. The next 5 questions are problem solving, right? That accounts for 80 points. So it's very similar to what we did in the midterm exam. So here are the following. So on the exam day, when you go to Canvas, to assignments, to final exam folder, you're gonna see 3 links. The first link is for the 10 multiple choice question. The second link is for question 11, 12, and 13, right? So 11, 12, and 13 are the value submission only questions, like in the midterm exam. So you read the information of all 3 questions at the beginning, and then you scroll down and you see all of the little questions, right? You just enter your values, and then at the end you hit the submit. You have until 2:50 to submit the second link. You have until 2:50 to submit the first link and the second link. For question 14 and 15, you need to handwrite, right? And then compile that as a single PDF file and submit that on Canvas. So the best way to have a single PDF file is you would open a blank Word file and then use a cell phone to scan or take pictures, right? And then you put the photos by photo in the Word file in the correct orders. And then at the end, you have the correct order and everything in one file, right? And then you convert it to the PDF file and submit that PDF file. The file name would be our class codes right here. FE for the final exam, your first name, your last name, right? Please write your first name on the first page so that I know right away who that is. All right, so during the exam time, you are not required to be on Zoom, right? But I will be on Zoom in case you need my help with something. Or if Zoom fails, and please communicate with me with the email address right here. All right, to prepare for the multiple choice, you will need to review the following topics, right? These are the topics after the midterm exam, not covered by the midterm exam. So in module 5, these are the topics. In module 6, these are the topics. Module 7, these are the topics. Some of the topics we do not cover it at all, so there's no need to review those. Okay. Basically, the slide, the class notes are the one that you review first, because definitely that's what we cover, right? The module 8 is a conceptual module, so please review the concepts. We only do the small calculation about producing and outsourcing at the end. Inventory management, you would, okay, so that's totally conceptual, right? Please review the concepts. And module 10, the fixed quantity system. So the EOQ is extensively covered in the textbook. So I already asked you to do this, right? Okay, you do not need to go over the topic that I cover, that I specify here, right? Okay, no need to do the review for question 11 and 12 for the multiple choice. Question module 11 and 12 are covered by the problem solving questions, right? So for the 5 problem solving questions, you need to review these 9 topics. Some of them are very easy, right? It sounds nice, it sounds like a lot, but actually some of them are very easy. Okay, so for topic number 1, you don't need to do the complex part, only part A and part B, okay? Just be careful about the topic 1. You don't need to do the C, part C. Part C is difficult, more difficult. You only need to do A and B. Process capability indexes, right? The 4 index that we learned, 4 indexes that we learned. The critical path method, that's question 25. The project with time uncertainty, question 26. I will grade these 2 questions for you soon so that we have some feedback on these 2 questions, okay? Producing and outsourcing, that's an easy question. You just calculate the cost and compare which option is cheaper. Then we're gonna go for the cheaper option, right? Topic 7, 8, and 9 are all of the modules, the topics that we talk about recently, right? FQS, FES, and SPI, right? So I hope that the class notes and everything will help you with reviewing those topics. The instruction of the exam actually down here. I already posted the instruction on Canvas, right? If you go on Canvas, you're gonna see everything over there. On the final exam day, you're gonna see the 3 links, right? The 3 actual links for the questions. Yes, Marco, I already have the review file posted on Canvas. The review file is partial at the moment because we have not submitted the remaining questions, right? So after tomorrow night, I will post the full review files where you see all the correct numerical answers to the 9 topics that might be tested in the exam. Okay, so that's yeah. So other than that, I would like to say that good luck with the exam. Okay, have a great winter break. Stay safe, and I would like to thank you everybody. Thank you all for joining me this semester, for staying from the beginning to the end like this. Thank you. I hope to see you back in the spring where we actually go back to the campus, okay, and we can chat. But for now, thank you for joining me this semester. Okay.
Thank you, Professor.
Thank you. I really appreciate it.
Thank you, Professor.
Thank you.